In this video, we're going to review lessons learned from our play about the princess and the monster. So, The Princess and the Monster is a fun story. It might seem like it's just silly, but it's actually been carefully crafted to help you remember details about how functions work in Python. So, in this video, we're going to be reviewing the lessons learned. I recommend watching this and maybe going back and rewatching the dramatic presentation after you view this video. So the first thing we know is that the princess doesn't know anything about the contents of the monster room. Remember, she knows how to get results from the monster room, but she doesn't know what's inside the monster room or really like anything that happens in there. And she doesn't know how to calculate the average speed on herself. She just knows that if she needs to calculate an average speed, she can run up to the tower. And then she places information into the two slots, the two requirements for that particular function, and then she just has to wait for the answer to pop out. So her actions represent like a main program that would be collecting information and then passing that information into a function, which we can view as a black box. And then she just has to go around and wait for the information to pop back out of the box for it to complete its calculation and return the information to her. Kind of along the same lines, the monster who lives inside the box doesn't really know anything about the princess or her life. He doesn't really even know there is a princess. He just knows sometimes paper pops into my box, and when it does, the various values need to be combined using my algorithm. And once I get the answer, I write it on a piece of paper and then push it out the exit slot, and then I get rewarded with chicken, and that makes me really happy. And whenever the monster's done with his calculations, he just like devours the paper that the answers were written on. He doesn't remember anything about the calculations he made or kind of the significance of the answer. He just knows, I made my calculation, I did my good work, now I'm going to get my chicken. So if we think about that in terms of Python, kind of how this code would be viewed would be that the princess algorithm is like your main program. It would be like your statements that gets executed whenever your Python program starts running. So if we were the princess, we would ask like the knight how far he's ridden and how many hours he's traveled. Then we push our values, the distance and time, into the slots for the average speed function, our black box. And then we also have to store the information that comes out of the black box, and we're storing that as the speed. We know that the result of the function gives us the speed that the knight traveled at. And then, of course, we can use that to communicate the information to other people, like the princess tells the knight at the end what his average speed was. And so we could display that as output from our main algorithm. But kind of the second part of the program is the monsters part. And the monster is like a function, and it's designed to be included at the top of our program. That's why we run up to the tower, to the monster's room, because we want to remember that the method definition goes at the top of the file. And the monster lives inside the average speed box. And we know that it takes two parameters, and the monster doesn't know that those are a distance or a time. It just thinks of them as value number 1 and value number 2. The monster knows how to combine those in an algorithm to get a result, and then it knows to push the result back out through a return statement to return information back to the person who kind of made the monster go into action. So those are the two pieces of the algorithm. Remember that the princess has a separate memory worksheet, something that's different than the monster's view of the data. The princess's memory worksheet, her clipboard, completely separate from the monster's memory worksheet or clipboard. They don't even know that the other person has a clipboard. And in the main program, the variables there aren't automatically connected with the variables that are in the function. So our distance and time that are in the main program, those don't get like automatically connected up with value 1 and value 2 by the computer. We have to tell it how to connect those by placing the values in the right order when we call our average speed function. So if the princess put the distance variable in slot 1 and the time variable in slot 2, she'd get the right answer. But if she mixed them up and she pushed time through slot 1 and distance through slot 2, she'd get an incorrect answer. She wouldn't get the expected result that she was looking for. And that's important. Whenever you're calling a function as a consumer of the function, you have to make sure that your argument values in your function call match the expected order in the parameter list. Remember that the function and the main program can use different variable names. That was true in our program. Our main function used distance and time, and the function used value 1 and value 2. And our function used average speed as the result, and then our main program used just speed to store the result. And again, those pieces of information are completely separate. There's no need that for the monster to coordinate with the princess to make sure everything's named the same way. The computer knows how to figure out which values you want to connect based on the order of the arguments and the selected variable that stores their return value. Remember that once the output's given, the monster kind of forgets everything about the calculation. It doesn't keep a record. There's no way to go back to a previous calculation that the monster's made. Once he returns the average speed, he pushes the answer out. He eats up all the pieces of paper that have the value 1 and value 2 on it, kind of devours them with the chicken. And then you don't remember anything about that later. And that's similar to how functions work when you call them in Python. If we call the function here, we can store the result that comes back in our own local variable for the main program. But if later on in the program we wanted to retrieve information about the distance or time or previous work, we wouldn't be able to do that. The only way we can get results is by calling the function and then storing the return value. There's no preserved information over time. There's no record of all the different function calls that have been made in your program. Another important thing to remember is that the monster room can be reused lots and lots of times. In our scenario, the princess only calls the monster room once to calculate one average speed. But there's certainly nothing stopping her from calling the method a second time to get a second speed by passing in some other value to see how fast that particular night ran. She could use literal values or she could use new variables, whatever kind of floats her boat. She's free to call on the monster as many times as she wants. And you can call on functions that you write as many times as you want in your main program. You might just call them one time, or they might be something that you call repeatedly in an algorithm. Either way is okay. Another idea that's kind of maybe non-obvious from this play is the idea that the castle actually could include other monster rooms. So in our scenario, the princess only interacts with the one monster room to calculate the average speed, but there could be a room to calculate the area of a circle, or a room to print out a greeting for somebody's birthday, and a room to validate a credit card number, a room to calculate a GPA. We could have all these different algorithms, and the princess has access to all of them. They all are available to her within the castle. And that's true for you too as a Python programmer. Any algorithm that you can think of can be turned into a function. The function just includes the Python instructions to carry out a particular algorithm. It's just a combination of the different tools that are in the programmer's toolbox, code that makes a particular algorithm work. And then you can combine them in any way that you see fit to create the algorithm for your monster room. If you had lots of monster rooms, you might store them in a library, like the Python standard library. Or you might store them in a file that you share with friends. That would be a local library. Or you could just create multiple functions within your own program where you're writing both the monster room code and the main program code. At the end of the notes, it talks about how next week we're going to look at some concrete examples of functions in Python. We've actually already done that. We did the notes about Python functions first, and now we're just using this fun play to kind of drive home some of the important themes about using functions in your program. The most important things for you to remember about Python functions is that if you're writing your own function, you want to put the definition at the top of your program. Then put all the statements that you want Python to execute when the program starts down here, and don't indent them. The fact that they're not indented helps Python to know these are where the execution of this file begins, not in this function definition itself. It knows because you put the reserved word def in here that this is just a function that your program has access to. And so it won't start executing the function until after the main program statements begin. It waits until it sees the name of your function, average speed in this case, and that's when it launches the function statement into action to carry out the algorithm. So it's one of the key things to remember. The function definition goes on the top. The other executable statements go on the bottom and aren't indented unless you have a loop or an if statement or something down here at the bottom. Another important thing to remember is that if your function returns information, like an average speed, you have to capture that information in your main program. Sometimes we capture that by saying like something equals and then including the function name. Sometimes we just want to display the result, and in those cases you can just say print and then put the function call inside there. That'll return the results and then immediately display it using the print statement. So either one of those is okay. And the third thing that's important to remember is that the computer matches up these argument values that are used in the function call with the order of the parameters in the function definition. If you remember those three key things, you are in good shape to write your own Python programs that include functions.